Hello, hello, and welcome to the Unit 7 quiz review video. Alright, for number 1, we're going to fill out these tables, we're going to show all our work, and we're going to graph the given functions. Alright, the first thing we're graphing is f of x equals 4 to the power of x. So we'll be doing this by putting it into your calculator. Let me quickly remind you, as I put my headphone back in my ear, that the way we enter into our calculator is we type the 4, and then we click this little button, this caret, and then you type the -2 that we have from x. You should get 1/16. You continue doing this over and over again, plugging in -1 for x, 0, 1, and 2. I recommend you pause this video and practice doing this on your calculator. I will not be helping you enter exponents on your calculator. This is something I expect you to do for the quiz. So go ahead and pause it, fill out the table, then unpause it and see if you got the same thing as me. Because I'm just gonna go ahead and fill it out because I can do it in my head. So here's our table. Everything we get is essentially a coordinate. So we plug in an x, we get out a y, because f of x is the same thing as y. So for example, this is a -2 1/16, -1 1/4, 0 1 1/4, and 2/16. I'm going to graph everything I'm comfortable with graphing. As long as you have that table complete, it's good for me. I feel comfortable starting at -1 1/4 because I feel that 1/4 is like an easy thing to estimate. It's a quarter. Next I have 0 1 1 4 and 2/16. Then I'm going to go ahead and connect them. It should look like a swoop that's flattening out at 0. Alright, let's try the next one. Number 2, we have the function 4 times 1/3 to the power of x. Just like last time, you're going to be putting this into your calculator and switching up the x's every time. Let me show you how to do the first one just so we can talk through it, and then just like number 1, pause the video, fill out the table, and see if we got the same thing. So in order to do this in your calculator, you'll type 4 parentheses 1 divided by 3 close parenthesis. You'll click the little caret button, and then you can type -2. When you put this into your calculator, you should get 36. That did not fit in. Let's use the magic of technology to make it smaller. Okay, go ahead, pause the video, fill out the table, and unpause it after you're done. Alright, for 4 times 1/3 to the power of -1, you get 12. Then 4, then 4/3, and then 4/9. Just like before, we get 5 points. Alright, looks like I think I can graph almost everything. Yeah. 4/9 is almost like a half-ish. So yeah, I think I can graph all of them. Graph what you feel comfortable with, okay? If you get all of them, perfect. If not, graph the whole numbers, but make sure it ends up looking the same as mine, right? Okay, -2, 36. It's going to be right here. That's negative. Yep, okay. -1, 12 is down here. 0, 4. 4/3 is 1 and 1/3. So I think it's here. And 4/9 is almost a half. I would get if you're not comfortable graphing 4/9, so 4/3 here. But you should still end up with this swoop. I got the swoop going downwards and flattening at 0. Gorgeous. Onwards we go. Right. In number 3 and 4, I'd like us to graph the exponential function with its graph. There's 2 ways of doing this. Of course, you can enter this into the graph function of your calculator and kind of match it up with a picture. Or you can go by the fact that the first number in an exponential function, this one, the one that's not the base, is our y-intercept. So we need a y-intercept of 0, 3. Okay, let's see if A has it. A is 0, 3. B is underneath 0. It's a negative number. C is a negative number. D is 0, 3 as well. Well, now we need to decide what kind of base do we have. Do we have a whole number or a fraction? Because there's a difference. If you take a look at number 1 and 2, our whole number swoops up, our fraction base swoops down. We have a whole number as a base, so we should be swooping up. Same idea for number 4. First, I'm identifying the y-intercept, 0, 5. Let's cross off everything that's not 0, +5. So that looks like, whoops, keep doing that. Looks like B and C, because those are both negative 5s. Okay. Next, I'm going to think about my base. My base is a fraction. In number 2, I think that's where we had our fraction. It swooped down. So letter D is our answer. All right. Number 5 and 6, we're going to find, 5 through 10. Okay, so we got graphs and we've got tables. We're going to write an exponential function. Reminder that exponential functions are f of x equals a times b to the x. A is our y-intercept and b is our pattern. We find our pattern by doing y2 divided by y1. So all this takes is identifying the y-intercept and a little bit of division. Let's do it. For our y-intercept, what we need to do is we need to look for a point that is 0, a number. Right? That's our y-intercept. So number 5, it's 0, 2. So there's our A term. Now we need to find B. In order to find B, let's write it down here. B equals y2 divided by y1. So let's pick 2 y's that are right next to each other. Let's call this first y y1, and let's call this second y y2. All right. B equals 10 divided by 50. 10 divided by 50 is 1/5. Well, we've got everything we need. Let's write our function. F of x equals 2 times 1/5 to the power of x. Let's try it again. Number 6. Our y-intercept is 0, 4. We found A. Now you get to pick whatever 2 y's you'd like. You can reuse 4 and make that y1 and make 36 y2. It's going to look messy if I do that, so I'm going to just do the next 2 y's. As long as our y's are in a row, like one after the other, you can use that. So, on that note, I'm going to call this y1, and I'm going to call this one y2. Okay. I'm going to scooch my screen. So, I need to find B by doing the second y, so 324, divided by my first y, 36. So, well, I don't like, oh no, that'll fit, I'll fit it. B is going to equal 9. Yeah, it fits. F of x equals 4 times 9 to the power of x. We're going to do the same thing for these graphs. We need to identify 2 points to use, and of course identify the y-intercept. I kind of prefer doing it off a graph, to be honest. First, let's identify the y-intercept. Here it is. There's our A. And all we need to do now is pick another point. It doesn't matter which point we pick if there's 3, as long as we use 2 in a row. So either we use -1 and the y-intercept or +1 and the y-intercept. I feel like using the +1. So this point is 1, 3. Now, before I find b, what I like to do is I set up a little table to make sure I divide in order. So here's my xy table. I'm going to put my x's in order. I have a 0 and a 1. So 0 and then 1. So I want that my x is getting larger. So then this is 6 and that's 3. y1, y2. And the purpose of these tables is to make sure we divide y2 divided by y1. Because if we did it backwards, we would get the wrong answer. Okay, let's find b. b equals 3 divided by 6. 3 divided by 6 is 1/2. F of x equals 6 times 1/2 to the power of x. In number 8, I only give you 2 points. First one is our y-intercept, 0, 2. Fantastic. And then this is 1, 8. Let's make a little xy table. X's go 0, then 1. So then I have a 2 and then an 8. y1, y2. b is going to equal 8 divided by 2. 8 divided by 2 is 4. So, here's our function. F of x equals 2 times 4 to the power of x. Okay, perfect. Let's move on to 9 and 10. So we got one more table and one more graph. Okay, now number 9, wow, I give you so many points. I give you decimals. Do you need to use those decimals? No. So let's identify the nice points that I gave you but didn't type out. No, how cruel of me. First, we got our y-intercept. And here are some normal points. 1, 10. Let's use that one, okay? Perfect. You could also use 220 if you wanted to. Actually, yeah, let's do that. Let's use those 2 other points, and let's leave that y-intercept alone. Okay, so I'm going to use the x's that are 1 and 2. So 10 and 20. Okay, y1, y2. If you wanted to, you could use the points I already labeled if you wanted to do those decimals. You would get the same thing. Actually, let me draw that on the side, because I definitely know there's some of you being like, what, Gumin? Well, if you were going to use -1 and -2, make sure, again, you're going from smallest to largest. So we would start with -2 and then -1. Right? So that's how your table would look like. You will still get the same answer as us. So let's see what we get here when we use whole numbers. b equals 20 divided by 10. That's going to equal 2. And here, if you did 2.5 divided by 1.25, you would also get 2. So here's our function. F of x equals 5 times 2 to the power of x. All right, last one here, number 10. First, whoops, I zoomed in way too fast. I hope I didn't make you dizzy. First, let's take a look at the y-intercept. Here it is. That's our A. Next, let's identify two y's. Let's just do the top two. y1, y2. B equals 1,250 divided by 6, whoops, wrong color, Gumin, 6,250. If you put that into your calculator, you would get 1/5. So our function is 10 times 1/5 to the power of x. I don't like how I wrote that. I'm going to try again. Beautiful. All right. So that was all about those exponential functions. Now, let's do a little flashback to properties of exponents. Okay. So let's simplify these exponential expressions, and we want to get them as only positive exponents. Okay, so in number 12, I see regular numbers, a's and b's. I'm going to chunk it up. I'm going to reorganize. All right, let's start with the regular numbers. I got 4 and 3. 4 times 3. Okay, times. Let's organize our a's. So I got a to the third and a to the negative fourth. And then let's organize our b's. B to the second, b to the negative third. Okay, now that I chunked them, I think it's going to be a little easier. So with the regular numbers, 4 times 3, well, that just becomes 12. When we're multiplying two of the same bases, like a's and b's, what we do is we add their exponents. So we get a to the power of 3 plus negative 4, and b is to the power of 2 plus negative 3. Let's keep simplifying. I think I'm going to have to make this a little smaller. 12 stays 12. There's nothing I can do with it. For a, I get an exponent of negative 1. And for b, I also get an exponent of negative 1. We can't have negative exponents. That was part of the instructions. So, reminder, every whole number and variable is technically over 1. So we're going to take those negative exponents and we're going to put them to the bottom of our fraction. When we have a negative exponent at the top of a fraction, it belongs at the bottom. If it's on the bottom, it belongs on the top. So 12 stays on the top of our fraction. It did not have a negative exponent. A goes to the bottom and gets a positive power of 1. B also goes on the bottom with a positive power of 1. Be careful. The most common mistake is when we take the negatives to the correct spot, you forget to make them positive. So make sure when you move them, when you flip them, they're positive. And that's our final answer. Well, let's try 13. Actually, yeah, let me make this a little smaller first before we try 13. Bloop. And smaller. Alright, I'll fix the box next. There. Box needs to be smaller too. Smaller. There. Perfect. Alright, 13. So for number 13, we have a power of a product. Or a product to a power. I want to remind you that anything that doesn't have an exponent actually has an invisible exponent of 1. So it's 4 to the power of 1 and 8 to the power of 3. When we raise a product that has a power to another power, we multiply the inside powers by the outside power. So let's see what we get. We get 4 to the power of 1 times 2 and 8 to the power of 3 times 2. 1 times 2 is 2, and 3 times 2 is 6. I can't do anything with 8 to the 6th, however, 4 to the power of 2 is 16. So my final answer is 16 times 8 to the power of 6. I don't remember if I told you this when we started 12, but on the quiz, I will have the power exponent rules right on there. I don't expect you to have them memorized quite yet. All right, number 14. The first thing I see here is that we have m's on top and bottom. There are 2 ways of going about this problem. One way is moving m to the negative 4th to the bottom and then multiplying. Or, what I think I'm going to do with you guys is, I'm going to go over the quotient property. The quotient property states that if we have 2 of the same bases being divided, we subtract their exponents. So let's review that. First, I'm going to break up this fraction into 2 fractions. The first fraction is just going to have regular numbers. So 3. There's nothing on the bottom, so I'm going to put a 1 as a placeholder. Now let's break up the m's. When we divide 2 of the same bases, we subtract their exponents. So, let's simplify. 3 over 1 is 3. And then we get m to the power of negative 4 minus 3. 3 stays 3. Negative 4 minus 3 is negative 7. We got a negative exponent. Let's take care of it. We're going to leave 3 on the top of our fraction because it's a whole number. But we're going to take m to the negative 7th, and we're going to place it on the bottom of our fraction as m to the positive 7th. And just to remind you that when we divide, we subtract our exponents. Let's take a look at number 15. Oh, we got 2 more. Cool. I don't know why I thought we had 17. Ooh, wow, 15 has so much. Let's chunk it up. All right, let's begin with regular numbers. I'm going to create a fraction. We got a 4 on top and an 8 on the bottom. Cool. Next, I see an x, just one type of x. So I'm going to put a 1 as a placeholder on the bottom because I can't just leave a fraction just all alone without anything on top and bottom. All right, next we got my y's. Y to the negative 2 and y to the negative 5th. And then lastly, I got my z's. Z to the 3rd and z to the 6th. Okay, this looks, I don't know, to me this looks way easier to solve. Okay, let's start with fraction number 1 with just regular numbers. Can I reduce 4/8? Could I do anything with it? If you're not sure, you can just type 4 divided by 8 into your calculator and click enter and see if it reduces that fraction at all. However, I hope you do know that 4/8 reduces to 1/2. It's a pretty popular one. All right, let's check out the second fraction. X to the power of 0. What's x to the power of 0? It's 1. Anything to the power of 0 is 1. So that's just 1 over 1. Wow, okay. Next we have our y's. When we have two bases being divided, we subtract their exponents. I'll write it out. We got y to the power of -2 minus -5. Same thing with the z's. I got z to the power of 3 minus 6. Very nice fact here. We can multiply these fractions. 1/2 times 1 over 1 is 1/2. That's pretty nice. For my y's, -2 minus -5 leaves me with +3. For my z's, 3 minus 6 is -3. All right, well, let's put that all together. Tops and bottoms of fractions. I have a 1 on the top of my fraction. I'll have y to the power of 3 because it's a positive whole variable on top of my fraction. On the bottom of my fraction, I have a 2, and I have z to the positive third. Do I really need to write that 1? Not really. I would prefer to just see this. Y to the power of 3 over 2 times z to the power of 3. Although this wouldn't be wrong either. You just don't really need that 1. And just as a reminder, when we put a negative exponent to the bottom, it becomes positive. Okay, last one. Number 16. All right, so here we have a quotient, so a division problem, raised to a power. The first thing that I'm going to do is rewrite it with that power, that invisible power of 1 in there for the 3. Okay. Now, just like raising a product to a power, when we raise a quotient to a power, we multiply all of the inside powers by the outside power. Let's do it. So, oops, we get, thank you, 3 to the power of 1 times -2. We get k to the power of 2 times -2. And m to the power of 4 times -2. 1 times -2 is -2. 2 times -2 is -4. And 4 times -2 is -8. You see how all the powers are negative? That quite literally means we are all on the wrong side of the fraction line. 3 to the power of 2 should actually, 3 to the power of -2 should be on the bottom as 3 to the positive 2. K to the -4 should be on the bottom as k to the positive 4. M to the -8 should be on the top as m to the positive 8. We just have one last step here. Can you tell what it is? We can take care of that 3, right? 3 squared is 9. M to the 8th stays here. K to the 4th stays there. Fantastic. If you have any questions about the quiz, please let me know before the quiz. Otherwise, have a wonderful rest of your day and best of luck. Bye.